Okay, good morning, good afternoon, and good evening, depending on where you're logging from. Thank you so much for joining today to GE Vernova's webinar, where we're going to discuss on how asset performance management, APM, will help you enable a reliable, safe, and profitable LNG operations. Before we get started, again, I wanted to say a big thank you for taking our time from your busy schedule and joining the session today. We have a lot of great content, and hopefully that will be really beneficial for the entire team who is joining today. Before we get started, a few housekeeping items, and if you have been to any of the GE Vernova's webinar, you must be used to it now. So this webinar is being recorded and would be made available to you on demand as long as you have registered for the webinar. Second, please feel free to submit your comments and questions via using the Q&A chat box. We'll try to reply it as we read through it, but we also have a dedicated Q&A session at the end of the webinar. And last, we do have additional content available in the resources center, which would be useful to you, which will give you additional information of all the products that we are going to discuss today. With that, just a highlight on the agenda. So today we have a packed agenda. We have a session close to 45 minutes where we will start with setting the context, where we'll talk about importance of LNG and also importance of APM within LNG. Then we will dive deeper, which is to discuss about how to enhance the reliability and integrity of both turbo machineries and static assets within LNG process. And we'll really highlight real-world case studies to support it. Last, we'll also now wrap up using the outcomes and the value realizations. And I think somebody needs to mute. Sorry, yeah, thank you. And finally, we'll end it with a live Q&A session at the end of it. So that's going to be the agenda. And now let's meet the presenters. It's just not me, but we have extreme talented colleagues that is going to join me. But let me introduce myself. My name is Vipin Nair. I am Director for Digital Product Management, managing the Meridium APM portfolio within software and control solutions of GE Vernova business. I've been with the company for more than 14 years and in the industry for close to 20 years. My background is mechanical engineering with a specialization in mechanical integrity. But for the last 10 years, I am focusing on building enterprise software asset performance management solution for process industries. I'm based in Roanoke, Virginia. So I'm glad to be here. I'll pass it to Truman Huang.
Thank you, Vipin. My name is Truman Huang. I'm looking forward to presenting to you all. I'm the technical product manager for SmartSignal, our advanced analytics, which I'll speak towards. I have 10 plus years within GE Vernova, both in product management and in services within SmartSignal. And prior to that, I have another 15 plus years in the oil and gas and chemicals industries as instrumentation and electrical engineering. Ernesto, I'll pass it to you. Ernesto, I'll put you on unmute here real quick. Okay, can you go again?
Yeah, thank you, Truman. So good day, good afternoon, good evening, everyone. So my name is Ernesto Varela. I am the APM Services Lead for the Functional Consultant team for Americas and Latin America. I bring more than 20 years experience in the oil and gas, LNG, petrochemical, and power generation. I've been working around 12 years as operating company, OpCo, before moving to consulting area, okay? My experience go across 4 continents in the consulting area, especially Middle East, Europe, Americas, and Latin America, okay? My focus has been helping industrial organizations improve asset integrity, reliability, and performance through APM implementation and enablement. Okay, I am pleased to be part of today's asset performance webinar, where we are going to show how LNG operator can improve reliability, safety, and profitability across their critical assets. My background is in mechanical engineer with a specialization in risk assessment. I am based in Houston, Texas. With that, I will hand over to Vipin and Truman, who will walk us through the LNG process and how the APM have been supporting LNG facilities for better operational excellence. Thank you.
Thank you, Ernesto. So again, before we get started, I'm just flashing some of the challenges here, which is more at the field level, but more I was thinking about it, I think it's important to talk about LNG in today's scenario, right? We all are aware that LNG is the most practical transition fuel and by far the cleanest fossil fuel. It produces 50% less carbon dioxide than coal and 30% less than oil when burned for power generation. So, and the global LNG demand is forecast to grow by more than 50% by 2040, with a lower carbon footprint than the fuel it replaces. But the challenging part comes because these plants now today have to operate at the intersection of the peak market demand and also operating under maximum mechanical stress, which is a combination that can lead to unplanned shutdowns and also production loss. And these are very highly consequential, which is not just impacting revenues, but it also delays the decarbonization commitments that we have built into the net zero pathways. So again, these challenges here, some of them I'll just call out as definitely aging infrastructure, right? Most of the LNG plants has been operating for more than 3 decades now. And we are also building new LNG plants to meet the demands. But aging infrastructure is definitely a concern. But the other concern is also the specific failure modes of various asset types in the LNG process. And we'll talk more about it. But we are talking about specific failure modes, and each are unique, and we need specific solutions to mitigate those failure modes. I'll also highlight few technical, which is IT related, which is siloed operation data, legacy systems, and data quality. Nothing new that you have heard, but it hinders the adoption of asset performance management. So again, going back, just take these as challenges, which is tactical, but the big takeaway which I'll take is the need for LNG to operate and provide the demand of the world as we transition to a cleaner energy tomorrow. For today's session, I wanted to provide you a visual of the LNG process. I feel the LNG process is simple from a step perspective, but yet so complex to deliver what it is supposed to deliver, right? The intent of it, the LNG plant, is to really liquefy natural gas, help you store and transport it via the LNG ship to various parts of the globe to the consumers. So if you look at the process, it starts with the initial feed compressors, which compress and feeds into the pre-treatment area, where you have a removal of the contaminants, including CO2, sulfur components, and water, which can freeze during the refrigeration cycle. And then you get into the first step of refrigeration, where the temperature is dropped to minus 35 degrees centigrade, which is happening in the pre-cooling train. Then it comes to the heart of the liquefaction, which we are calling as the liquefaction cycle, which really consists of the heat exchanger, which is the cryogenic heat exchangers, which is refrigerated using the mixed refrigerant compressors, and where the temperature is dropped to a minus 162 degrees centigrade. And that's where the magic happens, where the gas is converted into the liquid and where the volume is shrunk by almost 600 times, which is then stored in highly insulated storage tanks at that temperature, and then it is loaded into trains and exported across the globe. But what I would like us to take away from this diagram, again, is to highlight that the there are various asset types, right? Both rotating, which is turbo machinery, and critical fixed or static equipments, which has to work together as a system to deliver the output or the LNG, which needs to be exported out. So when we look at APM, it is very common for us to look at specific solutions catering to specific asset type. Okay, I need predictive analytics or a condition monitoring for my rotating asset. I need an RBI solution or an inspection tool for static. And that leads to siloed tools and siloed operations. But that's the topic of the webinar, that all these assets needs to work in tandem to deliver the value. And for today's webinar, even though we'll be focusing on rotating turbo machineries and fixed equipments, we also cater to electrical and instrumentation assets too. Now having discussed the process, let's just dive deep a bit more into the failure modes and the assets. So again, focusing or double clicking on the asset types. On the left-hand side, we are highlighting the rotating equipment that we just discussed in the previous slide, which is really dynamic and high energy asset to deliver that high pressure and low temperature requirements for LNG process. So we do have the main refrigeration compressors, which is the propane and the mixed refrigerant compressors. We do have the gas turbine drivers. Most of the cases, these gas turbines would be the GE Vernova frames, which includes the 5, the 7Es, and the 9Es, which is really driving some of the super LNG trains across the globe. We also have the feed gas and the boil-off gas compressors, and also the expander compressors and pumps. So it's very clear that we have a variety of turbo machineries operating at high speed, which gets us to the failure modes, right? So such complex equipments operating at this complex conditions leads to various failure modes, including compressor surge, bearing failures, dry gas seal, etc. And my colleague Truman will talk more about it on how APM, using SmartSignal, which is our predictive tool, health and reliability solution, help you mitigate these failure modes. On the same side, you do have the entire static and the fixed equipment asset profile, which is really pressure retaining, used for heat transfer and storage assets. We talked about the cryogenic heat exchangers, the pressure vessels, piping drums needed, the fin fan coolers, and finally the highly insulated, thickly insulated storage tanks and the relief systems which comes along with it. Similar to rotating, since these equipments are operating at very low temperature, high pressure, and also high temperatures, the temperature profile is so high, you have specific failure modes, including internal corrosion due to the contaminants, stress corrosion cracking, brittle fracture due to the cryogenic condition, and also the relief valve failures of the piping fatigue. And my colleague Ernesto will be talking in depth on how our integrity solution, along with reliability, can help you mitigate some of these failure modes. Just a reminder that the 3 to 8 metric ton per annum LNG trains typically operate at zero tolerance for unplanned shutdowns. So again, rotating and static assets needs to work together, and it demand predictive analytics, mechanical integrity, and also operator-driven reliability in tandem. So now let's take the next step, which is specific solutions which GE APM brings to the table to cater to both rotating assets, electrical instrumentation, and also the fixed equipment asset, managing reliability and integrity of the assets. So today we are going to focus on 4 pillars. One is SmartSignal. Again, Truman is going to cover it in details, but at a high level, this is our world-leading predictive analytics, which is based on physics-based models to really predict, diagnose, and forecast emerging failures. It can predict months or weeks in advance for various failure modes. And as I said, it gives you 30 to 90 days warning so that you can plan for the work. Again, I'll let Truman talk more about it. But also we have a holistic condition monitoring tool, which is called APM Health, which really helps you collate, unify, and analyze data from different sources. We have our own operator rounds solution, which is enabling your operators and also inspectors to collect data on a day-to-day basis. Along with that, we can integrate with your time series process historians, and it brings all this data together to help you calculate something called an asset health index, which is dynamic in nature, which gives you an idea what is the current health of the asset and helps you with what is the current risk of the asset. With both these critical information, we help you prioritize your work, both from a corrective perspective and also from your, optimizing your asset strategies. Truman will also touch upon it as he covers SmartSignal. We also have a critical pillar called APM reliability, which is really for both, again, rotating and your static asset, which is a comprehensive set of asset reliability analysis tools, which helps you reduce asset failures, controlling cost, and also increase production availability. And this is really by enabling a failure elimination or a defect elimination work process, and also provide a leading root cause analysis solution. So that's a different capability which is embedded within APM to support this work process. And last but not the least, which Ernesto is going to dive deep, which is our APM integrity. Again, world-class leading mechanical integrity solution, very focused for static and fixed equipment, which helps you calculate risk, manage your inspection database, and also help you manage your corrosion analysis data. We do have, two RBI calculators, both aligning to API 580, and one is aligning to the API 580 and RBI methodology. We help you manage your inspection plans. We provide you a detailed inspection database management. We recently launched a mobile solution, which is called Integrity Mobile, which is really focused and targeted towards inspectors, and also a world-class leading corrosion analysis, which helps you manage your CMLs/TMLs and provide you the remaining life calculations. So again, if you take a step back, it's just to remind that it's one solution managing multiple solution set, but also helping you all asset types that is needed to have your LNG operation reliable and running on demand. With that, I'll hand it over to Truman to dive deeper on the SmartSignal side and the APM Health side.
Thank you, Vipin. Thank you so much. So now that we've reviewed the broader challenges in the LNG value chain, Vipin did a great job laying them out to us a couple slides back. Let's take a look at a concept that applies to these challenges, and it's really fundamental to everything we'll be discussing here next. It's something that the maintenance and reliability folks in this audience will immediately recognize. This is the PF curve. Here's the critical insight for LNG operations. Traditional alarm-based solutions, they very often fire very late on this curve when you're already very close to functional failure. And this is really when operations and options are limited. Your costs to resolve are high, and the risk becomes very real, and reactiveness becomes really, all over the place at that point. So really what we're trying to do is leverage predictive analytics via SmartSignal within APM. We're trying to shift that detection point significantly to the left. This is what we're calling the early warning window, and it really enables the transition from reactive to predictive maintenance. This lead time is super critical in LNG operations because it allows you as a site personnel to align the maintenance with the planned downtime. This really helps ensure that a $2,000 part doesn't turn into a potential multi-million-dollar loss in production. So SmartSignal is that core engine in this predictive shift. It integrates into GE Vernova's APM, and it enables you to follow what we like to have as a 3-step framework: predict, diagnose, and prioritize. It analyzes process and mechanical data from your most critical LNG assets, So let's think main refrigeration compressors, gas turbine drivers, a lot of the things Vipin was showing in that value chain, in that end-to-end. And the power here lies in identifying really subtle deviations from normal behavior long before those alarms or limits are reached. And I'll get into that in a little bit here. So what we're trying to do here is allow you as a user to work alongside the software to ensure these aren't just alerts, but validated insights. So let's take a look a little deeper. Traditional alarms, as I mentioned, use fixed alarm thresholds, your DCS alarms. And that's the dotted horizontal line on the top you see in the graph there. So if, say, like a temperature sensor stays below that line, your system assumes it's good health. And very well possible, though, the asset is actually degrading. SmartSignal is going to use dynamic bands, that green envelope you're seeing there. And this band represents the model expected value. It's calculated in near real time, and it's based on the trained AI ML model in correlation with the current operational state, identified process driver sensors, and conditions such as ambient outside temperature. And I'll take a moment, I'm going to highlight the ambient temperature. This is really critical in LNG environments where examples of cryogenic conditions, can affect things such as seals and bearing lubrication and what have you. So really what this means in practice is SmartSignal knows that difference between a bearing temperature that's, say, simply elevated just because of ambient temperature and maybe a elevated ambient temperature versus a bearing temperature that is high because there's actually degradation occurring. Fixed alarm thresholds really cannot make that distinction, right? The system can detect this deviation in what we're calling a residual, and that's that green envelope you're seeing. It's the difference between the actual sensor data and the predicted value. And so because the model knows what the asset should be doing during that specific load and condition, it can flag issues weeks before it ever gets to that red dotted fixed alarm. Okay? So yeah, that detection is one thing. But really, to be effective, we need to know the why. And we also need that detection to be even more concrete. So this is where the solution employs multivariate diagnostics to address this. Instead of looking at these deviations for sensors individually and in silos, which can lead to potentially alarm fatigue, SmartSignal is looking at that correlation between multiple tags, better representing the asset's failure mode. So in this case, you're seeing first in this timeline, so left to right, priority 4 local bearing problem. And it's an early stage indicator. It's purely based on the bearing temperature, which is beginning to deviate. But right now it's just isolated to just that sensor. The system is flagging it as a priority 4, which is our lowest priority. And so a typical workflow can be, hey, this is really good information. Let's monitor it. Let's be aware of it. But perhaps no action yet, not yet critical. But as time progresses, the asset degradation might continue. SmartSignal starts to see and correlate deviations between this bearing metal temperature and the lube oil drain temperature and vibration levels. What you're seeing next then in this situation is a priority 2 cooling loss issue advisory. This is incorporated with other rules such as persistency, intensity, and hundreds of other rules that can be utilized to play a part into what is a much more precise and actionable alert, really allowing your maintenance teams to arrive at the asset with the right tools already in hand. So notice what just happened. SmartSignal didn't just tell you a sensor was high or deviating. Even from a similar-based modeling perspective, it told you the failure mechanism. It told you which subsystem was involved. It told you the likely root cause, and it gave you a priority level, so you know how urgently to act. This is really what we talk about when we talk about SmartSignal. It's looking across the multiple sensors simultaneously for problems rather than in silos. And for main refrigeration compressors on an LNG train, where consequences of missed bearing failure can be catastrophic, this is the difference between catching it proactively and identifying and discovering it during your peak export operations, or some of those new use cases that Vipin mentioned in the beginning of this webinar. So we have a diagnosis. Next question you may have, how long do I have? What we're showing here illustrates SmartSignal's time to action forecasting capabilities. SmartSignal forecasts when you might cross that asset's limits, which is like your DCS alarm set points. And in this specific bearing example, SmartSignal identifies the asset's going to reach a critical alarm in 10.8 days. So take a moment, think about having this level of detail, both here and what I showed in the slide before, and how that might change your actions and your strategies for your maintenance and operations teams. One way we see this helping is it changes the conversation to a prioritized scheduled activity instead, allowing you to manage your risks without potentially halting production prematurely, right? And so this all sounds great. And I think that you've maybe seen some of these before, but really it's important to get that value as soon as possible. And so rather than needing to build these failure modes and diagnostics for each asset type from scratch and engaging your subject matter experts or your operators to develop a lot of these failure modes, you can leverage GE Vernova's library of over 370 digital twin blueprints. These are SmartSignal models that can be built based on extensive experience, both as an OEM for some of these machines, and just as importantly, if not more, through having monitored these OEM and non-OEM assets with SmartSignal for over 3 decades. And I'll get into that a little bit more with our monitoring services. So this library covers your entire fleet's critical assets, regardless of the manufacturer, rotating equipment, fixed assets like heat exchangers, storage tanks, and even electrical instrumentation. And so for LNG specifically, these blueprints are trained to identify industry-specific failure modes like dry gas seal degradation or compressor surge, and I'll get into some of these use cases in a little bit. Okay, so that's kind of the context of how we work, how we create those failure modes. The prioritized part of those 3 items, we need to understand the risk of urgency. All this data is really not that useful unless we can translate it into action, right? GE Vernova's APM interface, really we're providing that single location for your reliability and maintenance engineers to collaborate. And that's through this streamlined alert management workflow capability and case management. This lets your team visualize the charting evidence. It helps you validate the importance of alerts in context with asset criticality and health, helps you document all those findings. It ensures the most urgent risks, such as the ones we've been talking about in the beginning, are mentioned and handled first, right? In an LNG facility, you may have hundreds of rotating and static assets, and you're monitoring all those simultaneously, right? This workflow is what turns that data into decisions, and then those decisions into actions. I really want to emphasize that any solution that would bring value, it really can't just be about, simple software notifications. It's about making your expert level reviews as efficiently, it's as understandable, repeatable, and accurate as possible. And that's where GE Vernova APM software, we really promote this human in the loop approach. Insights, they're reviewed, remediations planned, and parts and people are organized before the assets fails. And this data-driven collaboration ensures that the knowledge is retained within the APM system, creating a cycle of continuous improvement for your maintenance strategy. And this is what I said I'll get to in a little bit, but part of enabling that process can be through GE Vernova's industrial managed services. We realize that many LNG operators are facing aging workforces and many other constraints. And industrial managed services is a high touch service that allows GE Vernova as engineers act as really an extension of your team. And you can see a lot of the stats there. I'm not even going to mention too many of those. You can read the value there, right? 24/7 coverage. And the one I like to mention is the 60 plus catches per week as they are monitoring. Really, it's about giving you that peace of mind that you have experts watching your critical trains around the clock. And that's really the human in the loop combination, is world-class software, pre-built intelligence, and human expertise working together. But most importantly, I think I really hope this shows also just the proof of a technology that's making real world impact for users and their facilities, right? Okay, so let's take a look at some of this in action, right? I've got two examples here. Our first example involves gas turbine combustion. So the same type of GT drivers that may be powering your main refrigeration compressor trains in your facilities, right? I think we all know if this type of situation is missed, this problem could escalate very quickly. So in this case, it happened after a startup. SmartSignal detected a large cold spot in the combustion temperature profile. As a result, the exhaust temperature spreads, as you can see here, and you can calculate that anywhere. It was elevated, and it started to get to approaching the spread limit. And so, yes, the exhaust spreads were elevated, but still hadn't reached that trip limit, right? That red dotted line I mentioned in the earlier slide. So conventional alarm, would have stayed silent in this case, right? SmartSignal recognized the correlated deviations across these multiple thermocouple locations. It flagged it. It gave the team time to plan a borescope inspection rather than responding to, say, an emergency. And during that borescoping, they did find a tip burning on the fuel nozzle, minor black deposits on the liner, and by replacing the nozzle assembly early, they avoided major damage and unplanned shutdown. So calculations with this customer, there was an agreement. This really helped them with almost $600,000 US in estimated savings. And so this is an example of early detection, enabling that planned intervention, right, before the issue became much more serious. And it's a great example of the technology and the engineering teams working together to deliver that clear, specific, and actionable recommendation. Okay, the second case study we have here, it's demonstrating how early a SmartSignal can detect the problem. And in this case, we had an industrial managed services engineer alerting the site team to a very steady and slow increase in thrust bearing temperature over a long period of time. So we're not talking a sudden spike here, right? So this is if we go back to that PF curve scenario, we're talking way to the left there, right? The degradation had been developing for weeks. And thus with SmartSignal, already tracking it, already trending it, and in this case, escalating it. Now, bringing in the human in loop, performing a deep analysis, the team determined the unit needed to be derated until the next outage to prevent failure. And when the site team finally opened the unit, during that planned shutdown, they found early distress on the thrust pads. Because they had that months of lead time, they were able to, procure the parts, which had lead times involved, but they had them there on site, and they had all the resources ready to take care of the issue. So this catch avoided over, in this case, 6 months of unplanned downtime, helping protect the site's margins, right? And really downtime, that's what we put in here, but that's, not just production loss, it's also potentially things like, contract risk or even potential safety exposures. So, these are things to think about when we're talking about what we're trying to help solve here. And so, SmartSignal, I hope those, feel free to put questions in the chat. I'll take a look when I hand it over to Ernesto. Love to answer any other questions you have. And so hopefully you're seeing here that, SmartSignal is giving you that early warning based on your highest critical value rotating assets, weeks, months before potential functional failure. It tells you what's wrong, how urgent it is, and how much time you have to act. And in these examples you just saw, that does translate directly into avoided failures, controlled maintenance execution, and potential increase in protected production. But really, SmartSignal is one powerful piece of a larger picture, as Vipin touched on in the beginning. Predicting a failure really is only valuable if it connects to that decision. And I did show some of that capability with our alert and case workflow. But moving a step beyond that, making that right maintenance decision, whether to act now, plan for the next month, defer it safely, really requires that holistic view of asset health across your entire facility, right? And that's what APM Health delivers. That gives your operators, reliability engineers, maintenance planners, that single pane of glass where every asset in your facility has a quantified, data-driven health score, what we call the Asset Health Index. This is not just a gut feel. It's a numeric calculation of your asset's overall condition. It's contextualizing a lot of that sensor data, the equipment history, the rounds data, the information from alerts. And a great one is SmartSignal alerts, and a number of other things as well. So that way you can direct your attention and the resources you have to the assets that need it the most at a site, fleet, or even an enterprise level. And so that really progresses you. And what I hope you're hearing and seeing is moving from reactive to time-based to condition-based and predictive, moving further to the left in that PF curve. And that's, we believe, is the asset maintenance journey that everyone here on this webinar is working towards and trying to accomplish. And so SmartSignal, accelerates you to the predictive stage. APM Health is that foundation that makes the journey coherent and actionable across your whole facility. So with that, I'll pass it over to Ernesto to continue forward.
Okay. Thank you, Vipin and Truman, for that context. Now that we have seen the broader LNG operating context, we talk about LNG operator pain points, LNG process coverage, asset failure mode, and how predictive analytics, what Truman was mentioning, help to detect any abnormal condition in an early stage. Now, I would like to take the next step and focus on fixed equipment. So how APM helps LNG operators to get insight to manage risk more proactively across the different critical assets. Although rotating equipment often get the most attention because everybody knows that rotating equipment is the more dynamic asset, LNG reliability and safety also depend heavily on the fixed equipment, storage tank, piping, heat exchanger. So now let's begin with the fixed asset type and the failure mechanism, which already been mentioned, what operators need to manage, okay? So for the next slide, so the LNG facility, the main concern is not just the asset itself. It's about the failure mechanism that is being developed around the asset. For fixed equipment, only few risks stand out. A cryogenic condition, like Vipin mentioned, around 260 to 260 Fahrenheit, which is 162 degrees, tank and vessel can face embrittlement and potential brittle fracture. Right? This is the point that we are referring here. So piping and any pipelines may be exposed to external corrosion, erosion, stress corrosion cracking, depending on the service condition and contaminants. This is the case for piping. Heat exchanger and cold boxes equipment can be affected by leakage, fouling, corrosion, and thermal stress, all of which can be affect integrity and the performance. So the key point is simple. LNG operators need a disciplined way to identify where those degradation mechanisms are being developed, right? How critical they are and where actions should be prioritized first. Now, we also cover compressors and rotating equipment, right? Because those compressors and rotating equipment work together with the fixed equipment. Now, the next slide, we are going to show how APM, GE Vernova Meridium APM integrity capabilities come into place. So this is where GE Vernova APM becomes so powerful. And the reason is because we have a simpler integration between the different modules. When you go into your desktop and you sit together next to your digital solution, you will be able to see how the different solutions are integrated. By integrating inspection, risk-based inspection, and thickness monitoring together with compliance, all LNG operators can get much complete view of the asset health and integrity exposure. Instead of treating inspection as a standalone activity, GE Meridium APM connects degradation directly to the reliability outcomes. All LNG operators would like to see how reliable are their assets. And this is a critical shift for LNG operators. This means that we can proactively manage LNG-specific failure mode using a structured risk-based inspection. Now, we have different methodologies for risk-based inspection for LNG facilities. We have the RBI 581 methodology, which is fully quantitative, and we have RBI 580. So the 580 is a semi-quantitative approach. We are using a mix of different qualitative and quantitative approach. So that way we can offer to LNG customer a more dynamic and flexible risk-based inspection methodology. Now, we are using that data to prioritize what really matters. Improve maintenance timing, report and support compliance audit, and reduce the probability of any unexpected failures. Now, inspection management, okay, help to standardize and execute inspection workflow. We have inspection management planning workflow, inspection management execution workflow. For risk-based inspection, we focus mainly the resources on the asset with high critical, high risk analysis, and we analyze the probability and consequence of failures, okay? Now, for thickness monitoring, help to detect and train the degradation due to internal corrosion. And for compliance, helps to maintain consistency, traceability, and audit. So we can deploy and configure any government or country regulation by state, country, etc. So that way customer can comply with their potential outage. As Truman mentioned, APM help identify any process deviation or any emerging abnormal equipment behavior. When you are in the process condition, you have the operator 3 a.m. in the morning operating to the max to maximize production. So you have APM help connected to the other model or connected to the process condition. You are able to see any health signal that eventually will become integrity priority. This is where LNG operator will move from a simple scene alert to understanding what alert could mean for inspection scope, modification, mitigation planning, and any potential business risk. Now, this is not immediately. In some cases, it will take 1, 2, 3 weeks, months, but you have a single glass of paint where you can see all the different asset behavior. You will be able to take decisions based on data, okay? So at this stage, the biggest opportunity for LNG operator will be connecting predicted health insight with mechanical integrity. So any abnormal condition can be translated into practical inspection and maintenance decision. So the value is not one model, right? So we are connecting different models, okay? So that way the digital solution can talk to you guys. The value here comes from integration. So bringing together all this information will help to take more risk-informed decision. So we moved from time-based inspection to risk-based inspection, and risk-based inspection we can enable in a dynamic manner, okay? So let's check a case study where we are going to talk more concrete with real example how APM can enable more reliable LNG operations, okay? So this is for an European LNG terminal, okay, where we were working with a customer. So the challenge was customer was managing thousands of assets across the facility, but the maintenance program were not yet structured in a way that fully support efficiency and risk-based prioritization. They rely in time-based inspection, fixed interval overhauls, and they have to pay a lot of money and effort to keep doing the maintenance. All the asset master data need improvement. They were silos, okay? And they didn't have any systematic criticality assessment or framework, so that way they know where to focus the effort. So the action was to create a more comprehensive maintenance program that improve equipment availability, reliability, and cost efficiency, right? While also improving the quality of the underlying asset and maintenance data. So basically integrating all the different data sources in one area, so that way they can analyze, they can review together, they can have a single pane of glass, right? So the solution will be combined, GE Vernova, different solution, different workflow. That way customer can get insight and see real information, data quality to take action. Now, part of the solution was, first of all, asset register verification. So that way they can establish the right parent-child relationship. And in this case, we are talking about asset hierarchy. So asset hierarchy is very important. I will call this the framework. When we are in APM inspection, APM implementation, we focus in how the taxonomy, hierarchy, and classification is being set for the customer. Second, the framework for asset criticality assessment. So they have to understand, they have to go through the workflow for asset criticality, okay? So that way they can understand where to focus the effort. And third, the strategy methodology process. In this case, reliability center maintenance, RCN, where they were able to review and develop the strategy. So that way they can define the right tasks, what trigger to do a maintenance, and whether this time, this task will be time-based, condition-based, and they also focus in the failure mode condition or any other task that will have asset reliable. Now, the result was really significant. You can see in the right side. So how many assets were in the assessment? 25,000 assets. how many tasks were optimized? 73% of the tasks were optimized. In this case, those tasks were reviewed and optimized to get better value. And 17% of those tasks were eliminated. So these results show the value does not come from doing more maintenance, right? The value comes from doing the right maintenance on the right asset at the right time. And this is where integration matters. So when you integrate the different workflows, you get value. And always when we do implementation, we always talk about people, technology, and work processes. When you integrate people, technology, and work processes, you get value. Now, once they identify the asset criticality maintenance strategy, they will be able to get the health insight. And those inspection workflows were aligned. Operator can stop treating reliability, integrity, and maintenance as a siloed work process. This is where APM turns all these maintenance high volume activities into risk-informed value creation. So basically the integration allows to get those values. Now, beyond this case study, the broader takeaway is really clear, right? So the real value comes from to understand asset condition, which are the maintenance action we have to take, and how we connect the different operating models, right? So this is what I mentioned before, risk-based inspection dynamic. And this is where the next slide, I'm going to refer to the integrity operating window program. So that functionality is enabled in APM, and this is where operators turn insights into action before the degradation mechanism failure mode because a problem or a safety issue. Okay, so in the right side, you can see part of the user interface, how it looks like. Okay, and one of the more critical pathways to accelerate time to value is through escalate this IOW program through the LNG facilities. Now, why IOW program matter for LNG operators? Because you can detect any process deviation that can increase the risk of your asset before this deviation turns into potential failure. Now, how we enable IOW programs in LNG facilities? We align with API 584, okay, the work process that is being enabled in the API 584, because we support also the workflow by persona. We enable data setup for APM, IT, and OT data that include all the different degradation mechanisms. We have some content that have been developed, around 12, and this content will help visualization, better visualization, and overall risk profile for your asset. So what that means in practice, teams can act faster, and we are introducing also asset intelligence. When you get this data, you will have more better insight how to act, and based on, of course, real data. Now, Truman mentioned about APM health. So APM health and integrity workflow complement each other. Why? Because health analytics can detect change in operating patterns, and IOW define the limits that protect against that degradation mechanism that is being in evaluation. Now, together, they help team to recognize not just that something is changing, but whether that change is moving the asset into a condition where those degradation mechanisms can trigger a potential or final failure. This is important because operators, LNG operators, don't want to wait for the alarm, for the alert to fail, right? They want to be more proactive. So IOW is not about setting the limits, upper limit, lower limit. It's about getting the context. So to decide if you have to retire the asset for maintenance or you can continue with a safe operation. Okay. So now, with that in mind, this combination of IOW program where this information coming from IOW program will turn into action will turn into risk reduction, because if you act efficiently, your risk will go down. Also, this will improve alignment in the process team, between operation, integrity, reliability, because everyone is working from the same risk view, right? Everybody is working to maximize production and avoid failure. And this is where the next slide, I'm going to review what is the APM value realization. That way we can see clearly what is the benefit of having APM. Now, from the APM value realization, I'm going to close with this slide. Let's step back and look what value realization really means for LNG operators. So at the risk and safety level, APM helps to reduce exposure during any commissioning and early operation, lower the probability of failure, and avoiding any loss of containment events, right? So we can improve our audit workflow and support more safety, better safety performance. From the asset integrity point of view, we provide an early visibility, okay, for the different degradation mechanisms that have been analyzed across the different LNG facilities and enable more focused inspection, improve any post-turnaround reliability, and support more consistent equipment performance over the time. From the operational point of view, the benefits are equally important. APM helps to stabilize the LNG throughput and thermal efficiency, improve thermal availability, and also reduce the likelihood of unplanned downtime. Financially, also translate this into better protected cash flow, lower operating and maintenance costs, and better protection of revenue tied to any export commitment in the market. And from collaboration standpoint, APM improve alignment across reliability, maintenance, inspection, operation by giving all these team members one view of the risk, condition, and any priority that you have to do from the maintenance point of view. And most importantly, when operators connect SmartSignal or predictive analytic health monitoring with mechanical integrity and RBI workflow, they create a closed loop from detection to decision to intervention. That means early warning, better prioritization, more effective inspection planning, and stronger availability to prevent reliability events from becoming a really safety issue or any production loss event. So when we say APM enables reliable, safe, and profitable LNG operation, this is what it really means. Better visibility of your asset condition, better decision, better execution, and better business outcomes, okay? So thank you very much. And with that, I will take and we will open for any questions.
Thank you, Ernesto. I think that's been a jam-packed session from a content perspective. Considering that we are just 1 minute, I just want to remind that we'll respond to all the questions via email. But let me take one question from Philip. How do you get the different action recommendations? Do we need to configure them, or where do they come from? A great question, Philip. It originates from various sources, and actions or recommendation can be two types. One is corrective, which can come even from a predictive analytics that Truman just covered, and the IMS team reviews it, and that can be converted into a corrective recommendation, which can be then sent out to your EAM system. It can also originate from inspectors, the inspection workflow, or operators workflow. But there is also strategic recommendations. So for example, if you do a root cause analysis and one of the action is to update your strategies, we can use those recommendations to update your strategies, both from an RBI perspective or a reliability perspective. So again, there are different sources of action recommendation, and we manage it within the application depending on what is the work process there. Yeah. Do you have anything to add, Ernesto and Truman, on this one?
No, I think that's good, Vipin. Thank you.
Yeah, that will cover the answer clearly the question, Vipin. Thank you.
Yeah. I think considering respecting everybody's time, since we are on the top of the hour, again, thank you everyone for joining the session, for spending your time. We will send a follow-up email with elaborate responses to all the questions here. Have a great day. Thank you.
Thank you, everybody.
Thank you.